Welcome to the second session of the MIPI Debug webinar series. In this session, Jason will be presenting a preview of the MIPI security specification for debug. Jason is a technical contributor to the MIPI debug working group, and more specifically to the MIPI security specification. And he's also, in his day job, technical lead at Intel. So I'm just going to do a little bit of housekeeping, and then I'll hand over to Jason to start his presentation. So I'm Ian Smith, I work in the MIPI marketing team. I'll just be the moderator for today, and I'll next time you'll see me will be the Q&A session in around half an hour's time. Couple of notes: you can download the slide deck today from the handouts tab on the right-hand side of your screen. So you can download the slides in PDF format. We've also made available for download a recently updated MIPI white paper, which is entitled Architecture Overview for Debug, which should give you a complete overview of all the work that MIPI is doing in this space. Session is being recorded. We'll make it available via our resources section on the MIPI website as soon as possible after today's session completes. Planning to run for 45 minutes. That'll be around a 20 to 30 minute presentation from Jason, and then we'll follow that with around 10-15 minutes of Q&A. And on the subject of Q&A, please type your questions into the chat window as we go through the presentation, and we'll take your questions in the order that we receive them. So please do that as we go. Just quickly remind you that we've got 4 sessions this week. Earlier today we had how to get started with MIPI debug solution session. We have our security session now. Tomorrow morning we have the another session introducing MIPI Debug Over family specifications. Enrico will talk about the new philosophy around the Debug Over specifications. And tomorrow we'll introduce a new MIPI debug initiative, which is MIPI Debug Over UCIe. We'll have presenters from both MIPI and UCIe on that one. Okay, so without further ado, I'll flip to the agenda slide and I'll hand over to Jason.
Hello, hi everyone. So just a quick agenda slide. So we're going to motivate a little bit about the why we're creating a new specification. We'll talk through some specific parts of the specification that are added: the secure message layer, the secure communication management architecture options, and the session management. And then we'll talk through a very quick example application of the architecture to kind of get a flavor of what that might look like, summarize up a little bit, and then have time for Q&A afterwards. So why a new specification? So the first kind of thing we want to motivate is why is encryption important? We've been transitioning from more, I guess, non-standard interfaces to industry standard and shared buses like I3C, USB, etc. This mitigates challenges around debug control and data going over the shared protocols. Allows us to make sure that information that communication is secure and isn't being either tampered with or snooped on. And so what we'd want to specify here is really the standard mechanism to secure this debug communication between the target system and the debug tool system, as well as the management of that secure debug communication. Not much beyond that. And that goes to what we're doing the subject to, not unconstrained. Really what we're looking for is to address tool interoperability across our vendors, not the security objectives or algorithms or anything like that, as each vendor would have their own security objectives. So really focusing on standardizing the communication between devices and debug software, and not much beyond that. And in addition, we want to leverage industry standard protocols, specifically this SPDM protocol, so that we're leveraging the best of already existing security art, and really focusing for the specification on adding the debug communication specification, but not the security configuration and such. So specifically, what does the specification do? Well, it provides a secure message layer above the transport network layers, but below the MIPI sneak peek packet layer. It provides this secure communication management infrastructure API for managing these secure sessions, kind of architecturally formalizing a bit the interactions with the security processors or roots of trust, which may already exist in a vendor's product and may be usable. And then also provides a specified mechanism to control the secure session. In-band would be using sneak peek or a network adapter. We'll talk about that later in the presentation. And out-of-band would be implementation defined. And we'll again walk through those things a little bit later in the presentation. So let's take a look a little bit at the secure message layer. So let's do a little bit of a review. If you were in Enrico's earlier talk today, he brought a slide up, I think exactly a slide or maybe very similar, and mentioning the layering within the MIPI debug stack. So a link, a transport, our sneak peek adapter layer with a sneak peek layer with network adapters, and then higher level operations on top, including a sneak peek command engine. Enrico also had, I believe, this exact same figure or very similar, noting how this, when we add the security layer, how it is added within this message layering. It's added immediately below the sneak peek network layer, but above any of the transport or transport and network layer. And the reason why we did this was to have the trust boundary really be just between the TS and DTS. If we kind of looked at, if we moved the secure message layer down, we'd start to have more and more agents within the connectivity between the TS and DTS would need to be involved within the trust boundary. So this really simplified it for us to allow to transition across links, transports, whether you go over USB to some other protocol to something else, across between the DTS and TS, the secure message layer would still be encrypted end-to-end between the DTS and TS. But to do this, we need some sort of secure message format. The DMTF has a specification for something similar, this 277. It had a couple of limitations at the time that we wanted to I guess address. One was a type, and that was, I think, one of the really key aspects, because this type lets us have the control and data. And control here is the secure session control. Those packets, those messages need to not be encrypted to set up the SPDM, the secure session. And so this type was really needed and didn't exist in the 277 specification. Additionally, we added some tiny and full options to allow for be able to pack more data into one of these secure messages. And specifically, I put the exactly the changes. And it's as you can see, these are MAC covered if encrypted for the entirety of the payload, and then the encrypted aspect, the application data, that is encrypted as well. Switching layers a little bit to the secure communication of the management architectural options. Talked a little bit about how the message protocol works and kind of that message layer formatting. This now talks about how we architect the architectural components, and then example of architectural options for how this secure messaging can be done. So kind of our three architectural components here. We have a security agent. We have our message encryption or message authentication function. This is kind of like our encryption logic for the messages going back and forth. And then we have our secure communication management message path. So this would be like the SCM secure communication manager access space, which is defined already in the sneak peek specification. So let's look at how what those agents architectural aspects would look like in each of our kind of example architectural options. So this is communication, secure communication management going over sneak peek, in-band over sneak peek. So we have our security processor, which is it kind of maps to our secure communication management infrastructure. Our secure communication management message path is via the sneak peek command engine that lets the DTS use SPDM to establish a secure session. And then our secure message layer is where we do our message encryption or message authentication in secure message formats. And this is totally in band using sneak peek. Another option, which is using a network adapter, which is also in band but is more generic, I guess. Again, we have our security processor, which is our secure communication management infrastructure. Instead of using sneak peek packets, instead we can use a secure communication management network adapter instead to establish the session and control the secure session. And our secure message layer remains the same. And our last option is out of band, which is there's something that's not directly involved in the debug connection, the communication channel, but does control the secure messaging layer. And this is out of band and is done would be done not involving this connection, but would be done via some other connection, and the secure messaging layer would be notified with the appropriate secure message format and such. Okay, so establishing a session. And I mentioned this before, it's just in passing, so we'll go in a little more detail. We're using the SPDM specification defined in DMTF's DSP 0274. It's the industry standard protocol for establishing secure sessions, kind of aligned with the other MIPI security specifications. It has messaging, secure messaging, a protocol basically to establish a session keys for a secure communications session. It has several options in terms of pre-shared key usage or asymmetric key usage to establish that secure communication session. So it allows for a variety of options, and the intent is that vendors can reuse existing security infrastructure for something else that already requires this SPDM specification, because as Enrico mentioned in the earlier, in the first session, folks don't really want to pay for debug. So this reduces the barrier to adding this secure communication channel from an implementation perspective. And this MIPI defined in-band session management sends these messages via sneak peek, the SPDM messages, to send and manage sessions along with some control registers and such in the sneak peek access space. And the general kind of management flow diagram between the DTS and TS, the channel is activated, just the normal debug channel one would establish any of our debug over transport specifications. The DTS needs to identify the TS and identify the protection state to know if it's a requirement to the TS requires a secure session, or maybe the DTS wants to establish a secure session, and the DTS needs to ensure that the TS supports that. And then using the SPDM protocol, DTS then and TS both interact to establish that shared session keys. Once that's done, then normal debug can commence, and then at some point the DTS would end the debug session. Okay, and I guess this is going into some example application of the architecture of how one might build one of these. And we're going to look at just the sneak peek defined variant of the architecture. So again, looking at the sneak peek architecture, one could set something up like this. So we have our DTS connecting. We have our interface adapter controller, which is USB or I3C. Between that and the sneak peek engine and network adapter, there's this this message encryption, message authentication logic that's enabled, disabled by the SPDM secure session. So when the DTS wishes to establish a secure session or control it, it would interact with this secure communication management access space. And behind the access space, that allows access into the security agent to send these SPDM messages to the security agent. Based on those messages, when a session is established between the security agent and the DTS, and these session keys and IVs are derived, that information from the security agent is delivered to this message encryption and authentication logic. And the secure session is enabled with the message format. And then at that point, the DTS will be able to send the encrypted messages and have this logic encrypt and decrypt the outgoing and incoming messages for the normal debug traffic. So the specification does a couple of things, kind of revisiting. It really provides the management of an end-to-end secure session between the DTS and TS. And so we have this secure message layer above the transport and network layers, but below the sneak peek packet layer that we think is important for establishing the secure session at kind of the right layering. We have the secure communication management infrastructure API for managing these secure sessions that we kind of formalize our interaction with the security processor or root of trust via using the industry standard protocol SPDM to establish that secure session to negotiate the key material. And then finally, the mechanism to control the secure messaging gives you a couple of options. There's sneak peek or a network adapter for in-band control using the debug channel itself to set up the secure session, or out-of-band is implementation defined, but also can control the secure messaging. For more info about the how to get involved, especially if this is an interesting topic, here are the places to get info to get involved and download the white paper.
Thanks, Jason. We will have a dedicated web page for the security specification in due course. So if you check the MIPI website in a few days, weeks, we'll have that page up and running, a dedicated page for the debug security specification. Okay, so it's now a Q&A session. I have one question already. I was handling a system where you have some open and some secure components.
Yeah, so this secures it's a good question. It's kind of around the trust boundary, right? So this is the trust boundary is between the DTS and the TS, but from a debug transport perspective. So beyond that, it doesn't secure. There's no secure communication channel to an IP behind that. I think, Robert, that's maybe the question that you're asking. So it's really trying to address the problem of like imagine you have a board or something, and there are multiple places to plug into a shared bus that debug traffic is going over. Is there an option for someone to come in there and have a man in the middle attack, or to snoop traffic? That's kind of the problem statement this transport is looking at. This this specification is going to be looking at, not specifically the within a particular product, if there are some that are secure and unsecure. This doesn't really, I don't think this addresses that piece. Yeah, the transport, it's the secure session is within the MIPI, the transport, right? It's not specifically to a secure core, non-secure core. So there's options for what's covered within the secure session. So one could set it up so that certain network adapters are covered by the negotiated secure session and some aren't. So potentially if, say, there are a set of secure cores and a set of non-secure cores and some other partitionable across different network adapters, that could work. Robert's chatting in the chat and I'm seeing it. So he's asking, can you configure part of the system? It's, again, the scope is really around the MIPI network. And maybe I can go back a couple of slides. We do have a couple of examples of something like this. And so the secure communication management goes through to this networking layer, but it also can know what the network adapter is. So depending on which network adapter you want, you could set it up so that particular network adapters require a secure message setup link, and others don't. So so Robert, yes, you could. You would have to. There would be work to figure out how you would do it and how it meets the security objectives, right? Of what does a secure core mean versus a secure core mean? Yeah, it is possible, but there's probably, it would depend on what exactly you wanted to do. Yep.
Okay, great. Thanks, Robert, for that question and the clarifications in the chat. So I've got a couple of questions up my sleeve here. Obviously, Jason, you mentioned that this work sort of ties in with some other security specifications inside MIPI. Can you expand on that at all?
Yeah. So I think it aligns with MIPI to use the SPDM as kind of a basis. I think compared to some of the other specifications, it's kind of mentioned a bit, but it's not as prescriptive about what algorithm need to be run, need to be used, or anything like that. As you mentioned, debug folks don't really want to. Folks don't want to like add a specific security processor to meet a particular requirement on algorithm or something. So we're kind of the specific threat models, security objectives for securing these assets. From a debug specification perspective, we don't want to require anything there. That's really specific to the vendor and the product that's being used or defined. So I think that's kind of where it plays there, right? We're layering on the industry standard protocols, but really not putting much, if any, requirements on the actually secure algorithms and such that are used.
Okay, so you've got a lot of flexibility there for the person adopting the spec. Okay, I suppose that's another question, isn't it, about performance impact? Obviously, if you had a security layer, potentially you introduce a kind of performance issue into the system. Can you talk about that? I guess the framework kind of is as flexible as it can be to kind of ease these kind of problems.
Yeah. From like a DTS perspective, it's there'll probably be some latency to get the encryption going, but after that, you're probably pretty much bound by your compute performance on your debug test system. On the target system, it depends on what IP you're using to do the encryption and decryption. So it just really depends on the implementation perspective. It depends on the kind of cost benefit ratio of the implementation of the encryption and decryption logic.
Okay, great. Okay, I guess whenever we you talk about sort of security in a kind of more generic sense, there's always this kind of evolving threat landscape out there where new threats are come along, and perhaps new attack models are developed, and perhaps security becomes out of date, needs to be updated. How does the specification development kind of address that? How does it keep up to date?
Yeah, we tried hard to kind of mention a couple of times, but it comes across here too. We tried to make sure that the specification really doesn't prescribe anything from that security, from the security algorithm perspective or anything like that. It really layers on SPDM. So as SPDM evolves, as new security threats or improvements are found, we'd be able, the MIPI specification doesn't need to change. It should pick up whatever is in SPDM based on the SPDM version upgrades.
Yeah. Okay, clear. Okay, another question from Robert here. I don't know if it's one we'll be going to be able to answer. It's related to ARM products, but I'll throw it up there. ARM provides secure on-off for debug and trace subsystems. Is it possible to do so?
Okay, separated on-off. So you're saying you want, this would be secure for debug control and secure on-off for trace independently. It would be similar, I think, to the question and answer we had before. You could have multiple, I guess, network adapters that each could be controlled by different secure sessions, or doesn't have a secure session. So specification wise, that seems supportable. Yeah. Again, it would be dependent on the implementation and how exactly that would be routed through, but yeah. Non-secure debug. Yeah, at least the way I'm understanding it is, so the question is non-secure debug and secure trace, or the other way around. Yes, it would be, the specification allows you to, the implementer to have flexibility in terms of what, and the DTS, I should say, have flexibility into which network adapters have secure sessions enabled, and which ones potentially, if there's requirements on some being enabled, if another one's enabled. That would be all vendor specific and implementation specific.
Okay, got the thumbs up here from Robert on the chat, so I think we've
actually
his question.
I should, there is that information is propagated as part of the, it's kind of, there's a little bit of a info that goes into the transport, so that one, when we established a session, right, we went through that whole this whole management flow, right, identifying the protection state. There's a little bit of information into the transport to know, is a secure session enabled and which network adapters are covered by it. So that's where that information would come out. It's again, depending on the implementation, that the architecture and specification will let you do something like that. Yeah, that's a good question.
Okay, great. Thanks, Jason. If anyone's holding back any questions, now's the chance. I have one more question of my own, and then I think we'll probably likely wrap up. Simple question, I guess, Jason. This specification is work in progress. When can we expect it to be released?
I think we're targeting for like mid-2025.
Okay, so not too far away, another 6 months or so.
Yeah.
Okay, so heard it here first, folks. 6 months, we should have it should have it ready, and obviously we'll post updates via the MIPI website and MIPI blog as things progress. Oh, one last question, Rob.
Yeah.
Rob's at it again. Let's put this one
secure
up.
channel, non-secure channel. Yeah. You it's the secure channel would be with a network adapter. So yeah, you could secure some of them, not all of them. You could have different, if you wanted, you could have, for example, even within, let's say one wants to have a secure channel to all the network adapters. One might have different usage rates. So say we have a USB, USB, whatever the latest USB is, USB 4 connection for trace, and one for debug and control. And we're tracing something that's very, very chatty. We may want to have different secure sessions for both of them from a technical perspective, just to reduce the chance that debug is going to have to reestablish or update keys or something, compared to trace having the trace being very chatty, require things in debug that are not really related. So this kind of lets you do that if you wish as well. So you could kind of mix the number of secure sessions. You could have per network adapter, again, implementation specific, right? That support would need to be there, but from an architecture perspective, yeah, definitely could be done.
Okay, great. Thank you, Jason. I just have one additional slides to pop up on the screen. That's just to remind everyone that we've got 2 more sessions tomorrow. Enrico will be back, chair of the debug group, to talk about the MIPI Debug Over initiative. And then second up, we'll have member of the debug working group and a representative from UCIe come and talk about the MIPI Debug Over UCIe initiative. Give it a little bit of a preview about what we're doing there. So please join us tomorrow for those 2 sessions. Thank you, Jason, for your presentation, answering these questions, and thank you so much to our audience today for listening and submitting your questions. Really do appreciate it. Thanks a lot. We'll see you hopefully tomorrow. Thanks a lot now.
Thanks a lot. Bye.